Welcome to my game engine series. I'm working on a game engine since early 2022. It's written from scratch and it's making some progress. In this YouTube series, I'd like to show you what I'm doing. I'd like to show you how I designed and organized the game engine, and I'd like to share and discuss some techniques with you. The development is still ongoing, so I also like to share future features with you. My name is JC, aka Bowman Vienna. I'm self-taught when it comes to game engine development and also when it comes to Vulkan. I worked as an embedded programmer before, so I have used C in a long time, and I used C++ now for about 3 years. So enjoy the series. I hope you get some value out of it. Please do engage with me, share your feedback, clone the repository, review the code, debug the code, extend it, and have fun. To provide you with some context, the project is written in C++. The shaders for the GPU are written in GLSL. The build configuration tool that we're using is Premake 5, the graphics API Vulkan, and the game engine is developed on Linux. So Windows users, don't switch off just yet. All these components here are cross-platform. Vulkan and GLSL shaders work really well on Windows. Premake 5 can output Visual Studio project files. And C++ is also, for the most part, cross-platform. There are some areas that are platform-specific, such as the resource compiler and file access and also the entry point. So some of these areas I addressed already, not all of them, but pretty much everything that I'm going to be talking about in this YouTube series, everything about the GPU, Vulkan, shading, rendering, lighting, game engine development, and so on and so forth, also C++ concepts, is also applicable to Windows. So stick with me. You can find the code online here on GitHub. So let me show you the GitHub page. On Bowman Vienna Vulkan. So the features that are implemented at the moment is a Vulkan renderer with support for 2D and 3D. Then from the file formats, we support OBJ Wavefront and GLTF. Then in the shaders, we have physically based rendering, materials based on blenders, roughness metallic workflow, and we have normal mapping. Then we have point lights, directional lights with shadows, and deferred shading. In the application, there is some scene management with scene description files. Scenes can be loaded in the background while a cutscene is playing. There is a little bit scene editing possible, where objects can be moved around and scaled differently, and those scenes can also be saved. And there are attachable scripts. We have sound support that should work on Linux and Windows. However, there's also a Linux-only feature where the desktop settings can be controlled from the engine. Then we have hot plug gamepad support based on a controller database. We have a cross-platform resource system. There's a particle system. There's an event system for mouse, keyboard, controller, window, or game events. There's a settings manager and a message logger. Then the entity component system here, based on ENTT, plays a very central role. There's a physics simulator built in. Currently it's just 2D. So yeah, that could probably use some improvements. Then there are 2 GUIs available, one for in-game. So this one is for big picture mode. This one has a 10-foot UI. So this is pretty much optimized like for games and for a sofa experience. And then it also has a debug GUI. Then it supports sprite sheets. It comes with a little tool to generate sprite sheets, and it can animate sprite sheets. Then on the C++ side and design side, we have a render API abstraction, and there is a clear separation between the engine and an application. And you can also do profiling and output a JSON file that can be viewed in Chrome with Chrome tracing. The next item on the list is influences and inspirations. Here I wanted to explain how I learned about this topic, game engine development. I also wanted to give some credits, and I wanted to provide some important references to external resources. So a disclaimer up front, the YouTube series here is based on Brandon Galea's YouTube series called Vulkan C++ Game Engine Tutorials. So it's kind of mandatory to watch this if you want to fully appreciate the videos that I'm posting here. Then optionally, I recommend to watch from the Cherno, a game engine series about OpenGL and a 2D game engine. So in this series, a lot of important and basic concepts are explained. So it's definitely worth checking this one out. And then the Cherno also has a really good C++ series. So if your C++ is maybe a little bit rusty, definitely check out that one as well. So thank you to Brandon, thank you to the Cherno. You guys are awesome. Thank you so much. And one more credit I wanted to give the in-game GUI that I'm going to show in a little bit was inspired and quote-unquote borrowed from the open source emulator project PPSSP. So thank you to those guys as well. Before we go to the next topic, let's have a quick look at the engine itself. So here it starts. This is the splash screen. Here we have some shadows. We have a 2D overlay here. So with escape, you can activate the in-game GUI. One more time, escape to cancel it. And with M, you can see the debug GUI. We can here move objects around. So this will later be saved in the scene description. And yeah, you can change here the transform and experiment around a little bit. So then this one here is scene 2 at the moment. Let's go to scene 1. So the movement is with AWSD. This is a sprite sheet animation here. And one last thing I wanted to show is the normal mapping. So you can see there's a little bit of surface texture here. This one actually doesn't come from the model itself. That comes from something that's called a normal map, which contains surface information. And here is a debug feature. So where is it? So for the normal map, we can adjust the intensity here. So if I turn this intensity here to 0, you can see down here it becomes flat and dull. So this is the actual model that we're looking at now. And then if we crank this up here all the way, yeah, it becomes a texture. So normal maps are used, yeah, to yeah, when the lighting is calculated. So, well, this is pretty much the engine. So we have some point lights here. All this here are the PBR shaders. This movement here of the duck comes from a script. And then one more thing I wanted to show you. So here's the scene from above. This scene doesn't have a skybox, but what I wanted to show you here, this here is the particle system that I was also mentioning earlier. Oh yeah, and we should also take a quick look at the GUI, of course. So here is a controller setup. So here you can teach in the buttons. Here's the credits screen. You can change here the theme of the GUI. So yeah, that's just a quick look at the state of the engine right now. Let's exit here. On to the next topic. What are the goals for the engine? And what are the goals for the application? For the engine, in general, a goal is to have a really good looking and fast renderer. So I have a little overview here. Some of these items are implemented already, some are still missing, such as emissive materials, global illumination, ambient occlusion, reflections, anti-aliasing, guard rays, and bloom. So here's still a little bit work to be done, and we will definitely create some more videos on these topics. Then for the application, the goal is to create an actual game with a couple of levels where you can race against time, overcome obstacles, fight against enemies, and things like that. For the installation, head over to the GitHub page again, scroll down, and there are some build instructions for Linux and Windows. In general, you need Premake 5. If you are using Ubuntu, here's a PPA for that, but you can get it pretty much from wherever you like. For Linux or Ubuntu, here are some dependencies, some external dependencies to be installed. Then for both Windows and Linux, you need to get the Vulkan SDK from lunar.org. Then, when you clone the GitHub repository, be sure to say recurse submodules. That will fetch not only this repository, but all the repository that are linked in here. Then on Linux, to create makefiles, say premake 5 gmake 2. On Windows, that would be Premake 5 Visual Studio 2019 or Visual Studio 2020. Then on Linux, you want to decide with how many CPU cores you want to compile. So this goes into the shell variable called makeflags. If you want to compile on 4 of your cores, you want to use this one here, -J4. I would put this here in an INI file that is read in when you start the terminal, so that this shell variable is always present. Yeah, so then when you compile on Linux, you can choose between a debug and a release target. To compile the release target, you want to say make config release. And if you want to compile a debug target, you can say config equals debug, or you can just omit it and it will default to debug. And on Windows, once you created the Visual Studio project files, inside Visual Studio, switch to release or debug and compile it. The last topic for today is project folder organization. This is how it looks when it's freshly cloned. So here on the top level, we have most notably application and engine. This is where we will live most of the time. In the vendor folder, this is just third-party tools. Then resources here, these are engine resources. And the application has its own resource folder. Debian you can ignore, that's for Debian packaging if you want to upload the project to a PPA. And scripts here is also pretty empty. It's just for helper scripts. So the important folders. And here are the Premake 5 input files. Premake 5 Lua, this is the main one, which is then including this one, and in vendor there are some more. So all these here are static libraries, including that one. So the engine will also be linked as a static library to the application. So in this file, the application here is defined first, and then the engine is included as a static library. In the engine, we have these folders here. I can just read them for you. So there's audio, auxiliary, this is just helper functions, math, for profiling the instrumentation files, file support. Then for the event system, here resides the GUI. So this one here is the in-game GUI. We have a layer system. The logger is here. Then platform. This one here is platform dependent. So here's Vulkan. Here's all the Vulkan code. So here would also be OpenGL or DirectX 12 or Metal, if that would ever become a feature. Here's the renderer. So this one here is the API agnostic side. So none of these headers here include Vulkan headers, and so those headers here will be included in the application. Here is scene management, here's setting, here's the sprite sheet stuff, and in transform, yeah, here is some helper functions for matrices and for transformations. Yeah, so last but not least, in the application here, that is the entry point. That's the only file I'm going to show today. It's very minimalistic because the engine is linked as a static library to the application. I wanted the entry point to be here. In Lucre, here's the game state. Here's the main file actually of Lucre. So this one here would control the game state and would load the independent scenes. And here are resources. So here are the models, scene descriptions, scene scripts, and prefabs. And yeah, here's IMGUI. And here's also some extensions to the engine in-game GUI located. And that concludes the introduction to my game engine series. If you liked this video, please subscribe, hit the like button. If you can, please also like the Vulkan project on GitHub. Stay tuned and see you soon. Bye bye.